James Webb insane new exoplanet discovery shocks the entire space industry. Is life out there possible? If yes, then how far are we from it? What did James Webb Space Telescope discover this time? Well, there are so many questions related to exoplanets and extraterrestrial life, and all of these are connected to the James Webb Space Telescope. Today, in this video, we'll discuss everything. So guys, welcome back to the channel. Today, you are going to experience exoplanet discoveries of the JSWT, so sit back, relax, and enjoy the video. Webb and exoplanets. The James Webb Space Telescope will be used to examine the atmospheres of exoplanets in order to look for the building blocks of life elsewhere in the cosmos. However, Webb is an infrared telescope. What does this have to do with studying exoplanets? James Webb will employ the transit method to research exoplanets, which means it will look for the dimming of a star's light as its planet passes between us and the star. Astronomers refer to this as a transit. Collaboration with ground-based telescopes can assist us in calculating the mass of the planets using the radial velocity technique, i.e., detecting the star wobble generated by a planet's gravitational attraction, and then the James Webb Space Telescope will perform a spectroscopy of the planet's atmosphere. Webb will also be equipped with coronagraphs, which will allow direct imaging of exoplanets near bright stars. An exoplanet image would be only a place, not a big landscape, but by examining that spot, we can learn a lot about it. This includes its hue, seasonal changes, vegetation, rotation, and weather. How is this accomplished? Again, spectroscopy is the answer. Spectroscopy. The science of measuring the intensity of light at different wavelengths is known as spectroscopy. Spectra are graphical representations of these observations that hold the key to understanding the composition of extraterrestrial atmospheres. The starlight travels through the atmosphere of a planet when it passes in front of it. If the planet, for example, has sodium in its atmosphere, the star's spectrum, when combined with the planet's, will have what we term an absorption line in the spot of the spectra where we would expect to see sodium. Because different elements and molecules absorb light at different energies, we can predict where in a spectrum we could expect to see the signature of sodium or methane or water if it is present. Why is an infrared telescope essential for characterizing these exoplanets' atmospheres? The advantage of making infrared studies is that molecules in the atmospheres of exoplanets have the most spectral characteristics at infrared wavelengths. The ultimate goal, of course, is to discover a planet with an atmosphere similar to Earth's. The discovery was featured on the top pages of newspapers all over the world. Astronomers discovered a close-knit family of 7 Earth-sized planets orbiting TRAPPIST-1, a red dwarf star. Using ground and satellite observatories, scientists discovered one of the most bizarre planetary systems discovered beyond our Sun, raising the tantalizing question: are any of these worlds habitable? A potential home for life. 5 years later, the planets remain a mystery. Subsequent research has revealed that the TRAPPIST-1 planets are rocky, that they may be nearly twice as old as our solar system, and that they are situated 41 light-years from Earth. The recently launched James Webb Space Telescope, on the other hand, will be a game-changer. Webb, which is larger and more powerful than any previous space observatory, will search for evidence of atmospheres on the TRAPPIST-1 planets. That people can even ask the question of whether a planet surrounding another star is livable, that simply boggles my mind, said Sean Carey, manager of NASA's Jet Propulsion Laboratory in Southern California. Carey was a member of the team that used data from the now-retired Spitzer Space Telescope to discover some of the TRAPPIST-1 planets. TRAPPIST-1e, the 4th planet from the star, is a prime target for Webb. It's right in the midst of the habitable zone, commonly known as the Goldilocks zone by scientists. This is the orbital distance from a star at which the quantity of warmth is sufficient to allow liquid water on a planet's surface. Despite the fact that TRAPPIST-1 is surrounded by planets, the red dwarf star is not only far cooler than our Sun, but it is also just around 10% the size of our Sun. In fact, if the complete system were placed in our solar system, it would fit within the orbit of Mercury, our innermost planet. Searching for atmospheres. The habitable zone is only the first step. A possibly livable planet would also require a suitable atmosphere, and Webb's early observations are expected to provide just a limited indication of whether an atmosphere exists. What is at risk here is the first atmosphere characterization of a terrestrial Earth-sized planet in the habitable zone, said Michael Gillian, an astronomer at the University of Liège in Belgium and the lead author of the 2017 study that discovered the 7 sibling planets. The Hubble Space Telescope measurements provided new information concerning habitability. While Hubble does not have the ability to establish if the planets have potentially habitable atmospheres, it did discover that at least 3 of the planets, D, E, and F, do not appear to have the puffy, hydrogen-dominated atmospheres of gas giants in our solar system, such as Neptune. Such planets are regarded to have a lower chance of supporting life. According to Nicole Lewis, a planetary scientist at Cornell University, this leaves open the prospect of the atmosphere's potential to support liquid water on the surface. Lewis is part of a research team that will use the Webb Telescope to look for signs of an atmosphere on TRAPPIST-1e, the one with the Goldilocks perch in the habitable zone. We are hoping to observe carbon dioxide, which is a fairly strong feature, right at the wavelengths detectable by Webb, she explained. Once we know where there are little objects peeking out above the noise, we can go back and take a much closer look in that area. The TRAPPIST-1 planet size may potentially contribute to the case for habitability, however the research is far from convincing. They are comparable to Earth, not just in diameter, but also in mass, because to their close proximity to TRAPPIST-1, the planet's masses could be reduced. They jostle one another when packed shoulder to shoulder, allowing scientists to calculate their expected range of mass based on gravitational effects. The densities indicate that the planets could be made of components found on terrestrial worlds like Earth. Computer simulations of hypothetical planetary atmosphere creation and evolution are used by scientists to narrow down their possible composition, and these will be essential for the TRAPPIST-1 planets, according to Lewis. The beautiful thing about the TRAPPIST system is that it will allow us to develop those models in either direction, whether they wind up being just barren rock or possibly inhabited worlds, she explained. Another amazing feature of the TRAPPIST-1 system, according to Gillian, is its reach. I've seen TRAPPIST-1 in various artistic works. I've seen it in music, sci-fi literature, and comic books, he explained. That's something we've really loved over the last 5 years. It's as if the system has a mind of its own. So, is there life out there? Webb will tell us whether our solar system is unusual or normal. Alternatively, it may simply inform us whether or not there is a normal. There are numerous questions. What are the majority of solar systems like? Is it rare to find a planet like Earth, filled with water and orbiting in a somewhat nice habitable zone? Do our gas giants, such as Jupiter and Saturn, have atmospheres that are similar to those of other such behemoths? Webb will allow us to put our solar system in context for the first time, Lopez Morales added. However, it will not tell us whether a planet is home to life. Even if a world contains all of the necessary components, identifying life is far beyond the capability of even the most powerful space telescope ever created. Is it alive or dormant? That's a difficult question to answer. It's complicated because a variety of factors influence habitability. The atmosphere of a planet, like Venus's, may become exceedingly thick and heavy, eliminating the possibility of surface life. Perhaps a globe is abundant in water, but it is controlled by violent ice ages, providing few opportunities for life to thrive. This is all fundamental knowledge. It takes a lot of information to claim a planet like Earth, said Lopez Morales. So, this was all about this video. I hope you liked the information given in the video, and if you have anything on your mind, feel free to comment below. Also, don't forget to like, share, and subscribe to get more videos like this. Also, hit the bell icon to get the notification of the latest updates on our channel, and thanks for watching.